Okay, um, we're going to talk about a new kind of problem. So we're getting to the last part of the course here. We have one more big idea to talk about, and that idea is what if we start using multiple reactions all at once, or in sequence rather, start using multiples of these reactions that we know and start to really transform the compounds that we start with into the compounds that we want to make. So this is the idea of synthesis. It's a great big idea. It's something that we're going to practice a fair amount, and this is the big finish to Organic 1. All right, so let's look at a synthesis problem and think about how we would tackle it. All right. So here's a synthesis problem. So you're going to start here, and you have a starting material, you have a product. We've seen questions look like this before, but usually we've had only one step that converts starting material into product. In this case, we can't do this in one step. Can't do this in one step. All right, so and we haven't talked about a reaction that replaces hydrogens with bromines because, right, that's what we're doing here. Each of these in the starting material has a hydrogen at these positions, and in the product we have bromines. And so to figure this out, we have to one of the biggest strategies for synthesis is if we don't know a reaction that will work in the forward direction, we have to think backwards. Right? Okay, so let's imagine a question now that has this as our product. Right? And then we say, all right, what is the reactant and what is the starting material? Right? And we don't have, this doesn't have to be our starting material over here. Eventually we're going to sync these two things up. But for now, we're just going to say, if I just have this and I want to make this compound, how would I do that? And so if you think about this a little bit, you might say, okay, I've got two bromines that are attached to a double bond. Adding two bromines, especially in an anti-orientation like this looks like bromination to me. So if I do one equivalent of bromine and add it to a triple bond, right, now, okay, if I can make this triple bond, I can do a bromination reaction and make this. All right, so can I convert this double bond into a triple bond? We don't really have a way of doing that. If we want to add a pi bond to this, we need to have a leaving group. So now we've got an internal alkyne here. Here we had, what was this, a trans dibromoalkene. Okay, internal alkyne, how do we make internal alkynes? Well, we have two ways of we know how to make internal alkynes, right? One is elimination, the other is the SN2 of a terminal, the conjugate base of a terminal alkyne, right? So in this case, we can compare our structure here to our structure at the beginning. We notice we're not adding any carbons, right? This one has 14 carbons and our product has 14 carbons. And so we don't need to add new carbons in. So in this case, it probably makes sense to do an elimination. But once again, notice what we're doing is we're setting up, okay, what is my starting material and what are my reagents? Okay, so in this, if we're going to do an elimination to get there, we're going to need a strong base. I'm going to use LDA, but you can use whatever you want. And I'm going to use two equivalents. I should have left myself a bigger box. All right, so if I want to do two equivalents, then we go here, we got this, and we got bromine here, bromine here. Now, this almost looks like where we're going, but notice that the pi bond is gone here. But now I have two leaving groups, I have two equivalents of LDA, I can do a double elimination, right? E2 times 2, a double elimination to convert this dibromide into my alkyne. Okay, so now I've got this dibromide, and that's okay, we got a dibromide. And I look at this, I say, okay, well, what is my starting material that I can use to make this? And this looks like the product of a bromination, right? So if we do a bromination of this alkene, we get the dibromide. We can then do an elimination to make the triple bond, the internal alkyne. And then if we use one equivalent of Br2, we can make the trans dibromoalkene. So the strategy here to answer this question, so notice what we've done. First of all, let's take a step back and bask in the glory of this question, right? Notice what we've done here is we have strung together three reactions: bromination, elimination, bromination, right? And we've done that to convert a starting material into a product. And by stringing those three steps together, we've accomplished a transformation that we can't do in a single step, right? What are the things that are important to be able, so when you looked at this, you probably didn't look at this when I first put it up there and said, I know exactly what I'm going to have to do to figure this out, right? Even as I worked my way backwards, it might have taken you a minute or two to see what the next step was going to be as we worked backwards, right? And maybe I got there before you, and that's okay. I've had a little bit more experience doing this kind of thing. But what you're going to notice is the strategy is always kind of the same. So let's take a moment and really focus in on what are the skills that we're using to figure out what each of those steps is going to be, right? So notice that each time I identified what is the functional group, right? I said, oh, there's a trans dibromoalkene here. And it's not so important that you name the functional group, but we definitely want to look at this and say, oh, this is the part of this compound that I want to make, right? How do I make that, right? We don't circle the six-membered ring and say, oh, we need to make that six-membered ring, because there's not really any functional group there. It's just an alkane. We haven't really talked about ways to make alkanes. So when we look at this, hopefully this group jumps out at us and says, oh, that signals to me bromination, right? So the functional groups can signal what reactions are needed. Okay, so you may be feeling a sense of impending doom at this point, because what this means is that we have to really know our reactions well. We have to be able to look at a structure and say, that looks like the product of hydroboration. That looks like the product of hydrogenation, or whatever, right? That looks like an SN2 product. And we've been practicing this as we've gone through this course. So hopefully this isn't something that just comes out of the blue. It's important to know reactions. It's important to know what types of products these reactions make. Because once we figured this out and said, oh, this functional group indicates what reaction is needed, and that's the bromination of an internal alkyne, now I have another thing that I'm focusing on, right? Now I say, all right, once I draw this structure, now, maybe, now I'm focusing on this functional group. And I said, okay, it's an internal alkyne. What reaction do I know, right? The functional group determines the reaction that I want to have happen. Functional group implies the reaction. And so what reactions do I know that have internal alkynes as products? This leads me to the E2 elimination. And once I know that it's an E2 elimination, or once I guess, right, that it's an E2 elimination, then I know I need a strong base and I need some leaving groups. And so this functional group determines the next functional group that I'm going to use. So now I'm using this dibromide, right? And this is the last functional group that I'm really going to worry about, because now I say, okay, the dibromide, how do I make a dibromide like this? That leads me to bromination. And then we notice, of course, eventually this is going to sync back up with the starting material. The starting material is an alkene, and if I brominate an alkene, I get exactly the dibromide that I want. So one of our main strategies is to be experts at all of the organic reactions that we've learned in Organic 1. Easy, right? But the good news is that's what we've been practicing for over the last 2 or 3 months, is we've been learning all these reactions. We've been practicing all these reactions. I've had you predict the products of these reactions countless times, right? And the reason that I did that is because I was going to ask you to do it again here, right? And now we practiced it a whole bunch. It's going to be no problem.